This is a review of scatter plots and linear regressions. For question 1, it asks us to find the relationship between test scores and the number of incorrect answers. So in general, as the number of incorrect answers goes up, we should see the number of test scores going down. That's what's shown in this graph right here. So if we have like a high number of incorrect answers, we'll see we have a low test score. If we have a low number of incorrect answers, we have a high test score. For question 2, we're asked to find a negative correlation. Remember, in a negative correlation, as one variable goes up, the other variable goes down. In a positive correlation, both variables will be increasing or going up at the same time. So the amount of gas left in a car's tank and the amount of gas used in it. The number of gallons purchased and the amount paid. The tank size and the number of gallons it holds. Number of miles driven, and the amount of gas used. So we'll start with the last one. As the number of miles goes up, the amount of gas used would also go up, so that one would be positive. For number 3, the size of the car's tank and the number of gallons, well, the bigger the size, the more gallons it holds, that one's also going to be positive. For number 2, the amount of gallons purchased and the amount paid, well, as you purchase more gallons, it's going to cost more money. So lastly, just to confirm that number 1 is negative, the amount of gas left will decrease as the amount of gas used increases. So that one would be a negative correlation. Number 3 is we look at this cluster of data between the hours of sleep and the test score. First off, we would expect as you get more sleep, your scores will be better. So make sure to get some sleep before the Regents. But as we go up, we can see there is a positive correlation. As the number of hours goes up, so does the test scores. There's a general positive trend in the data. For question number 4, we're asked to take some information from the problem and create a linear regression. We have to round the data to the nearest hundredth and create the correlation coefficient. So I'm going to flip over to the TI-84 just to show how to calculate the linear regression equation and the correlation coefficient. So on your TI-84, you're going to want to go to the statistics, go into edit, and put all of your data in under list 1 and under list 2. I already did that to save us some time. After that, you're going to go back to stat, you're going to go over to calc, and you're going into number 4 where it says linear regression. We can see here the linear regression shows negative 7.756, so negative 7.76, plus 246.34. Just going to double check that really quick. Negative 7.76 plus 246.34. Okay, so that's our regression equation. However, we also have to find the correlation coefficient to the nearest hundredth. So you'll notice that when I look at my linear regression right here, it didn't tell me the correlation coefficient. That's because I haven't turned on diagnostics. There's 2 ways to do so. I can click on Mode and go down to Stat Diagnostics. This will only work, though, if you have a TI-84. The second way that you can do it is you can go to the catalog, which is found by pressing the second button and then 0, or the catalog. After that, you can scroll down till you get to D, or you can press the matrix or X-1D button to kind of jump ahead to diagnostic. And we want to go to where it says diagnostic on and then click enter. Once we've turned on the diagnostics, once we do linear regression, we will see the R value. So in this case, the R value is negative 0.876. Rounded to the nearest hundredth would be negative 0.88. All right, so let's talk about correlation coefficients. They can go from negative 1 to positive 1. If the number is 0, there's no correlation. And close to -1 is a strong negative. Close to +1 is a strong positive. So in this situation, we know we have a strong negative correlation. Well, what does that mean? As the distance from Times Square increases, the cost of the room is going to decrease. If you look at the graph, as one variable goes up, the other is going to be going down. So taking a look at this situation, we can say as the distance from Times Square increases, cost will decrease. All right. Question number 5 also asks us to do a correlation. In this situation, we're going from year 2007 to 2013, and they want us to make the regression when x equals 0 is used to represent 2007. So I'm going to take a second just to represent the years underneath here. 2007 would be year 0, 2008 is year 1, 2009 would be year 2, 2011 would be year 4, and 2013 would be year 6. So those are the data that I'm going to put into my calculator. I'm not going to put in 2007, 2008, 2009, and so forth. All right, so here we go. 0, 1, 2, 4, 6. If we go into stat, one tip, you can clear out all the data from a list by going up to the top and pressing clear. So for list 1, we had 0, 1, 2, 4, and 6. For list 2, our data is 8.3, 8.5, 8.5, 8.3, 8.5, 8.5, 8.8, and 9.3. Okay, once we've got all of our data in, we'll go to stat, we'll go over to calc, we'll do our regression. So in this case, we're asked to state the equation and the correlation coefficient. So our equation would be 0.15 or 0.16x and the y-intercept, the b value, we would round to be 8.27. All right, and then our r value, the correlation coefficient, is 0.97. It asks us to state whether this is a strong or a weak association, and we could say 0.97 is a strong association. We're not asked to explain any further, so that would be the final step for that question. Hopefully this was a helpful review of scatter plots and linear regression.